Hi everyone, my name is Matt Downen, and I'm a recent Ph.D. graduate from the University of Kansas in the Department of Geology. Although I'm not in Kansas anymore, I live in Kentucky right now, and today I'm going to take you on a virtual fossil collecting field trip to one of my favorite outcrops. At the bottom is limestone, and there are fossils in that, but just above it is this really thick shale unit, and the shale is full of fossils, and then you can see limestone up at the top. Okay, so we just took a few steps on the outcrop, and literally there's just fossils pouring out everywhere. So we're in the shale, and this is what it looks like, and you can already see there's all kinds of little pieces of fossils. Right here is a little rugose coral, and let's see. Here is a pretty long crinoid stem, or blastoid stem. So in this outcrop, basically the most abundant fossils are all of these sort of crinoid stems, there's bryozoans. So here's the horn coral. You can tell it's a horn coral, one, by the shape, because it looks like a horn, but also what's really distinctive about these fossils is the top part. So this is where the actual organism would have been, and you have these radiating lines that radiate out from the center. These are called septa, and that's one of the sort of main characteristics of a rugose coral or a horn coral. It also has this really textured outer wall. These are called rugae, which sort of have this wrinkled appearance. So here's a close-up again of the shale, and there's a bunch of little crinoid stems. Here's a little brachiopod. This is a little fenestrate bryozoan. A bunch of these other pieces are big pieces of bryozoans. Let's see. There's one, you can see all the little pores on the surface of this. There's another fenestrate bryozoan. This is one of sort of the little fronds. These are really lacy. Here, there's another piece of a bryozoan. This is actually sort of like the central axis of a bryozoan, of a fenestrate bryozoan. So all those lacy things would have attached and sort of spiraled around this central axis. And here's a piece of limestone, which is weathered out from above under some garbage. And this is basically entirely composed of crinoid stems or crinoid ossicles. So all those little circular things that you see is the stem of a crinoid in cross-section. There's also some bryozoans, some of those lacy fenestrate bryozoans. There's kind of a larger one. So here's another piece of limestone that has a ton of these fenestrate bryozoans. You can see they pretty much make up the whole rock, and there's also a little crinoid stem there at the bottom. So especially where this has weathered out, there's tons and tons of these bryozoans that are all just washing out. Pretty much everything I'm stepping on is a bryozoan, except for there's a crinoid stem. But most of this is all just tons and tons of these bryozoans. So here, this is something I have been looking for. This is called a blastoid. And blastoids are kind of like crinoids. But they're a little different. This is the top part of the blastoid. So this would have had tiny little arms coming out of here. And this is kind of squished a little bit, but it's relatively 3D. Okay, so we just crossed the road to go to the other side of the outcrop, and there's all kinds of fossils over here. So there's the outcrop that we were on, and now we were on here. I just came up this slope. There are all kinds of cool fossils here. There is actually a crinoid calyx, which is pretty cool. That's the bottom of it, and then there's the arms coming down. So here is another crinoid calyx. I'm gonna try to zoom in. So, well, it's actually not a calyx, but it's the arms. These are the arms of a crinoid. There's the little sort of feathery pinnules that are on the arms to help them filter feed. Okay, so there's all these sort of spiny things in here. These are probably echinoderm spines. And I actually found, so this crinoid calyx if you flip it over, you can see those spine things in there. So these are definitely part of crimewood calyxes, which is really, really cool. So Kentucky has tons of invertebrate fossils like this, but you can also find some similar invertebrate fossils in Kansas. So I hope you enjoyed the little virtual fossil collecting field trip, and happy National Fossil Day.
My name is Alyson Wilkins. I graduated from the University of Kansas in 2015 with a master's degree in museum studies. While at the University of Kansas, I found my passion in working with museum collections to help curate, manage, and care for them, as well as connect their information to the broader community, including everybody from everyday citizens to scientific researchers. While there, I worked with the paleobotany collections, helping to curate their collection of fossils, ranging from the Triassic flora of Antarctica to the flora of the Carboniferous. Since then, I've come to work here at the Natural History Museum of Utah. My job here is Collections Digitization Coordinator. Now, I know that sounds like a lot of fancy nonsense, but let me break it down for you. That basically means I work with all the major collections divisions, including anthropology, paleontology, entomology, botany, and much more, to help photograph their museum collections and their documentation to create new data, and then take that data and share it with the larger community so everybody can look at our fantastic collections. Here we have examples of various things we'd photograph. Everything from three-dimensional skulls of dinosaurs to mineral stalactites and to some of our wonderful paleobotany collection collected by Dr. Sid Ash. With these materials, we do everything from 2D photography and arrange it in a way so it looks consistent across the board. But we also use our camera equipment to help create fantastic 3D models so we can share them with our wonderful education team and with our exhibits team to help bring collections out from behind the scenes and share it with the people who come visit here. I recommend you go online and you check out our collections that we can share. First, we photograph on the photo station seen earlier in this video. Then, using photo editing software, we edit the individual pictures to create a consistent look so it's more easy to read the information and to share with the wider community. Examples you see here are from the Green River Formation from our paleobotany collection. Creating 3D models using two-dimensional photography is a process called photogrammetry. During the course of our regular photography, we'll take pictures all around the outside of an object to help create a better picture of what the object looks like in a digital space. But sometimes, even photogrammetry is not enough. We'll work with outside institutions and institutions on campus, as well as using our own laser scanners to create high-resolution models for research purposes. Using these models, you can measure to scale the size, shape, and bones, and you can also use models to help reconstruct damaged fossils. We're working on a wide variety of projects using 3D models of our collections materials. I recommend going to the Natural History Museum of Utah's website and checking out more. Happy National Fossil Day.